He never fired a gun in anger, never claimed a kill, never chased glory through the smoke of a dogfight. Yet by the winter of 1944, enemy pilots began avoiding the sectors where his formations flew. They had learned what others refused to believe, that mathematics, not courage, could kill you just as dead. The sky over Germany in late 1943 is a geometry of death. American bomber formations crawl east at 22,000 feet, their contrails etching white lines against the frozen stratosphere. Below, the patchwork farms of occupied Europe stretch toward a horizon already darkening with industrial haze. Above, the sun glints off something moving fast. Messerschmitt 109s, Focke-Wulf 190s. They come in pairs, in fours, in coordinated waves that have been refined through 3 years of brutal trial. The Luftwaffe fighter pilots are not beginners. Many have scores in the double digits. Some are aces twice over. They know the angles. They know the gaps in defensive fire. They know exactly where a B-17 bleeds when you cut it right. And the bombers keep falling. On November 29, 1943, the 8th Air Force sends 374 bombers toward Bremen. 40 do not return. The losses are not anomalies. They are trends. October was worse. The second raid on Schweinfurt in mid-October cost 60 bombers in a single afternoon. That is 600 men gone in 6 hours. The mathematics are unsustainable. Inside the cramped cockpits, pilots grip the yoke and hold formation. They have been trained to fly tight, to maintain the box, to trust the interlocking fields of fire from 10 50 caliber machine guns per aircraft. In theory, a well-flown combat box is a flying fortress. In practice, it is a predictable formation attacked by men who have studied every predictable thing about it. The gunners scan the sky, hands frozen even through heated gloves. The metal of the gun barrels is so cold it burns skin on contact. Oxygen masks fog with each shallow breath. At altitude, the temperature routinely drops to 50 below zero. Frostbite is common. So is hypoxia, flak fragmentation, and the sudden violence of a 20 cannon shell punching through aluminum skin. But it is the fighters that kill most consistently. They come from the sun. They come from below. They come head-on at closing speeds exceeding 500 miles per hour, a tactic that compresses the gunner's reaction time to less than 3 seconds. By the time a dorsal turret swings to meet the threat, the Focke-Wulf has already fired, rolled, and dropped away. The doctrine says hold formation. The doctrine says mutual support will prevail. The doctrine is written by men who have never felt a fighter's cannon rounds walk up the fuselage toward the cockpit. And then, quietly, in a windowless office at an airbase in eastern England, a man who has never been shot begins to suspect the doctrine is wrong. If this history matters to you, tap like and subscribe. His name is John Robert Boyd, though in 1943 he is not yet the theorist history will remember. He is 26 years old, lean, bespectacled, with the slightly hunched posture of someone who has spent too many hours at a drafting table. He does not look like a fighter pilot. He looks like an engineer because that is what he was before the war. A man more comfortable with slide rules than control sticks, with graphs than gunfire. Boyd grew up in Erie, Pennsylvania, in a household where precision mattered. His father worked as a toolmaker, a trade that demanded tolerances measured in thousandths of an inch. Dinner conversations revolved around tensile strength, load factors, and the elegant problem-solving required to turn raw metal into functional machinery. Boyd absorbed this language early. By the time he was 12, he could disassemble a carburetor and sketch its operation from memory. He was not a natural pilot. His first flight training reports describe him as competent but overly cautious. He thinks too much, one instructor noted. He questions the why before executing the how. In a training environment designed to produce instinctive reaction, Boyd's tendency to pause and analyze is seen as a flaw. But the Army Air Forces need pilots, and the standards flex to meet the demand. Boyd earns his wings in early 1943. He is assigned not to fighters, where reflexes matter, but to bombers, where systems and coordination dominate. Specifically, he is sent to the 447th Bombardment Group, a B-17 unit forming up at Rattlesden, a flat, muddy airbase in Suffolk, England. He arrives in August 1943, just as the 8th Air Force is ramping up its daylight bombing campaign. Rattlesden is new construction, Nissen huts, PSP runways, and the ever-present stink of aviation fuel and wet concrete. The base is loud with the sound of Wright Cyclone engines being tested, ground crews shouting over the noise, and the low rumble of fully loaded bombers taxiing out before dawn. Boyd is assigned as a co-pilot. It is a secondary role. The aircraft commander makes the decisions. The co-pilot monitors instruments, adjusts throttles, and takes over if the commander is incapacitated. It is also a role that affords time to observe. And Boyd observes everything. He notices that some crews return consistently while others do not. He notices that certain formations seem to attract more attacks. He notices that the gunners, brave as they are, rarely hit anything. Tracers arc out into empty sky. Fighters flash past untouched. The 50 caliber guns sound authoritative, but the actual hit rate is abysmal. He begins to collect data. Between missions, while other pilots play poker or write letters home, Boyd walks the flight line with a notepad. He asks gunners where the fighters came from. He asks navigators what altitude they held. He asks radio operators if they heard enemy chatter on the frequencies. He sketches attack angles. He notes sun position, cloud cover, and the timing of enemy passes. No one has asked him to do this. At night, in the dim light of a hut heated by a single coal stove, Boyd plots the information on graph paper. He is looking for patterns, repetitions, the hidden rules that govern why some bombers burn and others survive. His bunkmates think he is obsessive. One calls him the professor. Another asks, half joking, if he plans to teach the Luftwaffe geometry. Boyd does not respond. He is too focused on a shape beginning to emerge from the data, a shape that suggests the enemy is not random, that the chaos of combat hides a system, and that the system, once understood, can be countered. But first, he has to prove it to people who do not want to listen. The problem is not that American bomber formations lack firepower. A single B-17G carries 13 50 caliber machine guns. A standard combat box of 18 bombers puts 234 gun barrels into the air. The theoretical weight of fire is devastating. Luftwaffe pilots should be shredded attempting to close. They are not. By December 1943, 8th Air Force loss rates hover near 10% per mission. Over the course of a standard 25-mission tour, a crewman's statistical chance of survival is roughly 1 in 4. These are not acceptable odds. These are attrition rates that hollow out entire groups. The fighter escort helps when it can reach the target. P-47 Thunderbolts accompany the bombers partway, but their range is limited. Once the escorts turn back, the bombers are alone. It is in these unescorted windows that the killing happens. The official response is to tighten the formations. The logic is straightforward. More bombers closer together equals more overlapping fields of fire. The combat box becomes denser. Wingtips sometimes fly within 50 feet of each other. Pilots strain to hold position. One moment of inattention, one gust of turbulence, and two bombers can collide. Mid-air collisions are not rare. But the tighter formations do not reduce losses. In some cases, they increase them. Boyd begins to suspect why. He takes his data to his squadron commander, a career officer named Major Howard. Boyd explains that the current defensive formation is predictable, that the Luftwaffe has studied it, that the angles of attack are chosen specifically to exploit gaps in fire coverage. He suggests that the problem is not firepower but positioning. Major Howard listens politely. Then he tells Boyd to focus on flying his airplane and let the tacticians handle tactics. Boyd tries again, this time bringing charts. He shows how enemy fighters approach from the 12 o'clock high position because the nose guns on a B-17 have limited traverse. He shows how the ball turret gunner cannot engage targets directly below during the fighters' roll away. He shows how the waist gunners, firing from opposite sides, often create crossing fire that endangers friendly aircraft more than enemies. The response is the same. Doctrine exists for a reason. Bomber Command has analysts. They have studied the problem. The formations will hold. Boyd does not argue. He is too junior. But he also does not stop collecting data. In early January 1944, a new element enters his calculations. The Luftwaffe begins using a tactic called company front attacks. Instead of single fighters or pairs, they send entire Staffeln, up to a dozen aircraft, in massed frontal assaults. The fighters line up abreast, wings nearly touching, and bore straight into the bomber formation. The combined firepower of 12 20 cannons firing simultaneously is enough to dismantle a B-17 in seconds. It is terrifyingly effective. It is also, Boyd realizes, desperate. The Germans are losing experienced pilots. The replacements are younger, less skilled. A head-on pass requires less precision than a diving or beam attack. It is a tactic designed for volume, not finesse, and it is deeply vulnerable to one thing: the timing. If a bomber formation could anticipate the attack angle and shift position at the last moment, the massed fighters would be forced to adjust mid-run. That adjustment, even if only a few degrees, would scatter their fire. The closing speed is so high that even a 1-second delay in reacquisition means overshooting the target. But the idea requires two things: advance warning and coordinated maneuver. Both are considered impossible. Advance warning depends on spotting the enemy early, which is difficult against sun, glare, and cloud. Coordinated maneuver requires hundreds of pilots, flying heavy bombers in tight formation, to execute simultaneous course changes without breaking the box. Bomber Command considers such precision unachievable. Boyd thinks otherwise. He begins sketching a new formation geometry, one that preserves mutual fire support but introduces variability, one that forces the attacking fighters to choose between bad angles and no angles, one that uses calculus, not courage, as the primary defense. He calls it offset stacking, and he knows that no one will approve it unless he can prove it works. The idea comes to him fully formed on a night in late January. Boyd is lying awake in his bunk, listening to the wind rattle the corrugated metal of the Nissen hut. Outside, the darkness is total. Blackout regulations mean no lights, no glow from windows, nothing to guide enemy bombers. The base is silent except for the distant growl of a single engine being tested on the far side of the field. He is thinking about geometry. A bomber formation is three-dimensional: length, width, altitude. The Luftwaffe attacks from angles that exploit predictable spacing. But what if the spacing itself became unpredictable? Not random. Randomness is just another kind of chaos, but systematically variable. A formation that appears standard from a distance but reveals asymmetry only when the attacker commits. The key is offset altitude. Current doctrine stacks bombers in neat layers, each element precisely 500 feet above or below the next. This makes navigation easier. It also makes the formation a vertical grid, easy to read, easy to attack. But if the altitude intervals varied, 600 feet here, 400 there, the visual cues the enemy relies on would degrade. More importantly, the fields of fire would overlap differently. A gun that cannot depress low enough to cover one angle might suddenly have clear line of sight if the aircraft below is 50 feet lower than expected. The waist gunners, previously firing across empty space, could now interlock fire into zones the enemy considers safe. Boyd sketches it out on paper. He uses trigonometry to calculate sight lines. He factors in gun traverse limits, closing speeds, and reaction times. The math is tedious but conclusive. The offset stacking creates a defensive envelope that is 15% denser in the critical frontal arc. 15% might not sound like much. In terms of survival, it is the difference between a fighter pilot attempting a head-on pass and deciding it is not worth the risk. Boyd writes a formal proposal. He submits it through channels. It goes to his squadron operations officer, then to group, then to wing. He waits, days pass, then weeks. In early February, he receives a reply. The proposal is declined. The reasoning is bureaucratic. The offset stacking requires retraining navigators and bombardiers. It complicates formation assembly. It introduces risk of mid-air collision. And most critically, it deviates from doctrine that has been tested and approved at the highest levels. Boyd is told, again, to focus on his duties. But there is a gap in the system, a small one. Training flights. Every week, the 447th runs practice formations over the English countryside. These flights are not combat missions, which means they are not strictly governed by operational orders. Flight leads have discretion to test maneuvers, adjust spacing, and experiment within safe parameters. Boyd is scheduled to lead one such training flight on February 14, 1944. He says nothing to his superiors. He says nothing to his crew. But the night before the flight, he briefs his fellow pilots in quiet tones. He explains the offset stacking. He shows them the math. He tells them what he wants to attempt. Some are skeptical. One asks what happens if they screw up and collide. Boyd answers simply, "We do not collide." The next morning, 6 B-17s lift off from Rattlesden into cold, clear air. The bombers climb through 3,000 feet and level off over the Suffolk coast. The formation is loose at first, each aircraft finding its place by sight and spacing. Boyd's voice comes over the radio, calm and deliberate. He calls out headings and altitude adjustments in precise increments. The other pilots follow. Slowly, the formation begins to shift. The standard combat box is a rectangle, 3 elements of 2 aircraft each, stacked in clean layers. Boyd's version is subtly different. The second element flies 400 feet above the first, not 500. The third element is offset laterally by 200 feet and elevated by 600. From above, the formation still looks cohesive. From the front, it is asymmetric. The pilots hold it for 10 minutes. Then Boyd calls for a simulated defensive maneuver. He instructs the formation to execute a coordinated turn of 15 degrees while maintaining the offset intervals. This is harder than it sounds. A turn changes relative positions. The inside aircraft must slow. The outside aircraft must accelerate. Altitude must be adjusted continuously to prevent drift. They execute it. Not perfectly, one bomber drifts high and has to correct. Another lags and closes the gap too quickly, but the formation does not break. The offset holds. Boyd is listening to the chatter from the gunners. Over the intercom, they report their fields of fire. The ball turret gunner notes improved depression angles. The top turret reports clear sight lines into zones previously blocked by the lead element. The waist gunners, normally isolated, now have overlapping coverage in the forward quarter. It is working. Boyd presses further. He calls for a second maneuver, a shallow dive followed by a climbing turn. This simulates evasive action during an attack. The bombers push forward speed building, then pull up in unison. The offset intervals compress slightly but do not collapse. One of the pilots radios back. He is grinning, though Boyd cannot see it. He says the formation feels different, more responsive, less rigid. Boyd does not celebrate yet. He knows the test is incomplete. A training flight over England is not the same as combat over Germany. There are no fighters here, no flak, no fear clouding judgment, but the mathematics do not change. If the geometry works in theory and holds in practice, it will work under fire. He lands the formation back at Rattlesden and says nothing. But word spreads. The gunners talk to other gunners. The pilots talk to other pilots. By the next morning, crews are asking if Boyd's formation is going to be used in combat. The operations officer hears the chatter and calls Boyd into his office. The conversation is brief. Boyd is told that unsanctioned tactical experiments are not acceptable, that he overstepped, that if he pulls something like that again, he will be grounded. But the operations officer does not order him to stop talking about it. And 3 days later, a different squadron commander, a man named Captain Roth, known for unconventional thinking, asks Boyd to brief his crews. Boyd does. He brings his charts, he explains the math, he walks them through the offset intervals and the rationale. Roth listens without interrupting. At the end, he asks one question. Can this be done in combat? Boyd says yes. Roth assigns him to fly lead on the next mission. February 20, 1944. Target, Leipzig. The mission is deep into Germany. It will be heavily defended. The Luftwaffe will come in force. Boyd has one chance to prove that calculation can defeat instinct. And the stakes are 600 men riding in 36 bombers that will cross the enemy coast at dawn. The bombers assemble over the North Sea in darkness. Each group climbs through cloud, navigation lights blinking until formation is achieved, then extinguished. By the time the sun rises, 300 B-17s are stacked in a stream stretching 40 miles. The 447th is near the front. Boyd's squadron is in the lead element. They cross into occupied Europe at 7:20 hours. Below the Dutch coast is a gray line against grayer water. The land beyond is flat and featureless, fields divided by canals that reflect the early light. There is no flak yet. The Germans are waiting. Boyd's formation is flying the offset stack. He has briefed it twice, once the night before, once again in the pre-dawn dark of the briefing hut. The pilots know their positions. The navigators know their altitude marks. The gunners know what to expect. There is no drama, just numbers and discipline. At 8:05, the first flak appears. Black puffs bloom at 21,000 feet, walking across the sky in clusters. The formations do not deviate. The flak is predicted, prepositioned. The German radar stations have calculated the altitude and course. The shells burst where the bombers were, not where they are. Boyd makes a minor course adjustment, 5 degrees north, enough to shift the formation out of the flak corridor without losing the stream. The other bombers follow. The flak continues but falls behind. At 8:40, the fighter attacks begin. The Luftwaffe comes from the north, climbing out of cloud cover. Focke-Wulf 190s, 12 of them in company front. They level off 3 miles ahead, wings nearly touching, nosing over into the attack run. Closing speed, 520 miles per hour. Time to contact, 34 seconds. The bomber gunners open fire at 2,000 yards. Tracers arc out, 50 caliber rounds traveling at 2,900 feet per second. The fighters do not waver. They are committed. Boyd's voice comes over the radio, steady, no emotion. He calls for a coordinated 5-degree descent and a 3-degree turn to port. The maneuver is slight, almost imperceptible. The bombers respond. The formation dips and shifts. The fighters adjust. But the adjustment costs them 2 seconds. 2 seconds at closing speed means 1,500 feet. The range compresses faster than expected. The lead German fighter opens fire early, his 20 rounds falling short. The fighters behind him fire in sequence, but the staggered timing scatters the impact. One burst hits a B-17 in the waist, punching through without striking anything vital. Another rips through empty air where the bomber would have been if it had not descended. The fighters flash past. The bombers are intact. The gunners report hits on 2 enemy aircraft. One trails smoke. The other breaks formation and dives away. The rest regroup for another pass. Boyd's offset formation holds. Over the next 40 minutes, the Luftwaffe makes 6 more attacks. Each time, Boyd times the defensive maneuver to disrupt their firing solution. The bombers do not break formation. They do not panic. They execute, as trained, the calculated adjustments that turn precision attacks into guesswork. By the time the formation reaches Leipzig, 2 bombers have been hit hard enough to drop out. Both make it back to Allied lines and crash land in France. The crews survive. In a standard formation, the expected loss rate for this mission profile would have been 8 to 10 aircraft. Boyd loses 2. The bombing run is successful. The formation turns west and begins the long flight home. The Luftwaffe does not return. They have lost 5 fighters, and the bombers they attacked refuse to behave as expected. Boyd lands at Rattlesden at 15:20 hours. The ground crews are counting holes. His bomber has 37, none are critical. He climbs out, legs stiff from 6 hours in the seat, and walks to the debriefing hut. The intelligence officer asks him to describe the mission. Boyd does in flat, factual terms. He mentions the offset stack. He mentions the timed maneuvers. The intelligence officer writes it down. 2 days later, 8th Air Force Headquarters sends an analyst to Rattlesden. 3 weeks after that, the offset stacking geometry is incorporated into revised formation doctrine. By April 1944, loss rates across the 8th Air Force begin to decline. The war does not end because of one man's math. But it bends, slightly, in directions that favor those who calculate over those who merely endure. By the summer of 1944, bomber formations across England are flying variations of Boyd's offset geometry. The changes are subtle. Most crews do not know where the adjustments originated. They simply follow the new doctrine and notice over time that fewer bombers are burning. The Luftwaffe notices, too. German fighter pilots begin reporting that American formations are harder to read. The predictable spacing is gone. Attack angles that once guaranteed hits now result in wasted passes. Veteran pilots adapt. Newer pilots, rushed through training to replace staggering losses, struggle. The casualty rate among Luftwaffe fighters climbs. Boyd himself flies 19 more missions. He survives the war without injury. His bomber, nicknamed the Skeptic by his crew, returns to the United States in late 1945 and is scrapped for aluminum. Boyd does not stay in the military. He returns to Pennsylvania, finishes an engineering degree, and takes a job with a defense contractor. He works on avionics, flight control systems, and eventually, the mathematics of air combat maneuvering. In the 1960s, his theories on energy management in dogfighting become the foundation for modern fighter tactics. The Boyd cycle, later called the OODA loop, becomes doctrine. But he never speaks publicly about the bomber formations. When asked late in life why he pursued the offset stacking idea when it was rejected by superiors, Boyd answers simply. He says the math was correct, and correct ideas do not require permission to be true. He dies in 1997. His obituary in the New York Times mentions his contributions to fighter tactics. It does not mention the winter of 1944 or the 600 men who came home because a co-pilot with a notepad believed that geometry could save lives. The data, however, survives. 8th Air Force loss rates in early 1944, 9.1% per mission. By late spring, after the tactical revisions, 4.3%. That difference represents roughly 2,000 airmen who did not die, 300 bombers that did not burn, and a strategic bombing campaign that continued long enough to dismantle the Nazi war machine. Boyd never claimed credit. He did not need to. The numbers spoke for themselves. And in the vast, indifferent calculus of war, where courage and chaos are measured in equal weight, there remains a quiet truth. Sometimes the greatest weapon is not the one that fires, but the mind that sees the pattern before the bullet flies.